It's great to have a good friend here. So Xinyu from Jinko was very kind to offer us a presentation. It's quite rare. You also allow us to film that. So people that don't know, Xinyu did his undergrad here. He graduated in 2010 and then he moved to the ANU, and he did his PhD on passivation with Andreas. 2016 he joined Jinko and he's the director of the R&D. He came to visit part of the collaboration between Jinko and UNSW, and again, he was very kind to suggest that he will speak with us a bit about R&D and what's their direction to the near future. So please welcome Xinyu.
Thank you, Steve. Thank you everyone for coming to this talk, and I give great thanks to Ziv for organizing this event. It's just really a pleasure for me. I kind of feel a little bit nervous since, like, see the cameras and it's quite formal. So for me, I feel it's more like a sharing opportunity with people that about some progress we have done at our work, and also have some communications with people here at UNSW for their progress at the research activities. And for me, it's a great chance to gain some learning experience again at UNSW. It's very difficult to have a very good talk for a long time without having people try to sell you a tool or something. So I hope today we have more chance to have some discussions and Q&A, so that also something will inspire me as well. So then we can set up future collaborations. That would be great. So let's move on. So the topic for today's talk is about the progress and outlook at the industrial level R&D for photovoltaic products. It's not only solar cells, but also for modules and also some related products. So it will be in 4 parts. The first part will be some brief introduction of Jinko and about the company, about the products, and also particularly about the R&D center at Jinko. So I'll try to make it short. Don't look like an advertisement. So here at Jinko, we are a integration PV manufacturer. We do products from the solar wafer growth to the cutting and until the PV systems. So in the past few years, we have done relatively good work. So for the last year, the shipment for modules is about 9.7 gigawatt, which is the number 1 for last year. And this year, our target is around more than 12 gigawatts. So I hope we can also meet that target again. And currently, we have 7 manufacturing factories globally, including in China, Malaysia, and a few other countries for the modules. And the branches are worldwide, and 23 branches. Here in Australia, we have 1 branch in Brisbane and also a small office here in Sydney. We totally have 3 R&D departments, and 2 are for product R&D located in Shangrao, and also a testing lab in Malaysia as well. We are one of the frontier companies for the PV products and also the application. So here's briefly our map for the global network. So currently, I think we are in a stage that a transition from a company with global business to a globalized company. So we cannot say we are completely globalized company, because a lot of things are still based on a very particular markets and a very particular manufacturing basis. But things will change rapidly, especially in recent years. The automation and what we call smart manufacturing is gaining a lot of interest. So people will have more flexibility on the manufacturing and sales and the transportation. So the global network will be more tense and more efficient. So in the main product family, still based on a very conventional and mainstream products, such as the aluminum BSF solar cells and modules for both multicrystalline and monocrystalline. And also for high efficiencies, we do PERC solar cells, and we have done quite good job on this. And since this year, we will have new product launch for N-type, so that will be another product series. So here a little bit of performance for our product. We have a good reputation for good performing products, like for the power generation computations, we always rank very high, many times rank #1 and many times like top 3. And also the quality is also an important part of our product. So we have good high quality assurance, so that we are one of the top runner project suppliers in China. And so we have a few records for the quality insurance, such as the first one to achieve a CQC certificate, and also of course for both CQC and CGC, we are a popular supplier for the top runners. And so we have at the bottom we show that this range mainly for multi, but for mono we can reach shipment power of around 320 watt. That is a mainstream, so we can provide such a quite large throughput for this, which a good achievement last year. So a brief introduction of our R&D center. So here, our R&D center is one of the state key labs. So we have, so this building looks very nice, and it's our solar cell R&D department. So we have our laboratory here, and also we have another pilot line for our projects and techniques application that's in another building. The total areas for our R&D center is around is more than 7,000 square meter for the solar cell, and for the whole R&D center is above like 15,000 square meters. And the main group for our R&D research is based on some engineers with various background, and we have more than 10 PhD graduates, and most of the group is actually has a master degree. For the research equipment, we have, due to the large invest for the past few years, we have a lot of equipment that is ongoing there. So that's a good chance for everyone. If someone want to collaborate with us and have the access, we can definitely talk. And so the ambition and targets for R&D center is to definitely get higher efficiency for the solar cells, solar modules, and also as a result of the integration, we provide the user to have a high power generation and a good electricity generation. Of course, another key label for Jinko product is the reliability and the quality. So we definitely want to guarantee the reliability and the quality for our product for the whole lifetime. All right, so in the second part, I will present some typical work we have done last year and some good representative achievement here. So last year we have achieved for P-type multi-silicon solar cells, we have achieved a world record of 22.04, certified by Fraunhofer, I see. And that's for large cells, that is currently the world record. And of course, one of our KPI for this year is to break this record again. I believe it's going to be very hard, but we'll try our best. So for the high efficiency P-type solar cells, we use PERC structures. Of course, here I think everybody is quite familiar with PERC structure, and in the industrial level. So since we have the capability to do a lot of experiments, so we can gain some very hands-on experience. So we know how to do the optimization and stuff. So that will be a key point why we can achieve high efficiency. Not too much magic here, just to optimize everything, and a little bit techniques that we imply. Okay, so then we can move on. So for high efficiency solar and module techniques, apart from the record, we have a few internal targets we have been met, which is made us quite proud. Such as the P-type mono, we actually have the best cell. We can reach an efficiency of 23.405. That's with novel metallization design. And also a advanced structure average, we can reach more than 23. That's for a batch result. So that's a very good result as well. And for the mass production average, it is above 21.7. That is for the production line, not only for the R&D. So it's like a daily running. Now it can reach more than 21.8 due to improvement of the wafer quality. For the N-type solar cells, we are mainly working on the PERT structure and also some high efficiency structure. So for the PERT, the best cell for us is about 22.5. That is also a batch is being made in the pilot line, not in the lab. And mass production average is above 21.9. The main gap between these two is actually due to the quality variation of the solar wafers. These days, it's very difficult to get high quality N-type wafers, which is as a matter of fact. So for the best part of the wafer, we can then apply those wafers to our high efficiency solar cells, and then for that type of structure, we can achieve 24 and with certified values. So that is the baseline of our work for this year. We will try to improve everything here. I hope if we have chance to come back again next year, I hope the numbers will increase. Okay, so for the solar modules, so we have been keeping the record for power for the module power for both P-type for both mono and the multi P-type modules, 6P. So with some high efficiency tags from the solar cells and also some high efficiency techniques from the solar modules. So that apparently is the best module, but that is definitely a goal for us to achieve for the next few years for our full range of products. We are targeting the high power. So apart from the efficiencies, the quality and the reliability is a great part of our product and also a great part of our R&D work. So I will mention that later in the next session. So, so improving the solar product quality is directly related to the benefit and profit you have from the market. So we pay a lot of attention onto that. We are the first one to achieve a Q+ certification, and also now we can provide many users in several regions the triple time IEC certification. That means when you have an IEC test, you have a certain test sequence and test conditions. When you do the double or triple IEC, then you means you have to make the testing more strict, like 2 times or 3 times. And by that, you need some new input into the technologies. And also, we pay attention to many other reliability-related areas, like the PID. We are the first one in the industry to solve the PID issues. That is around 5 years ago. So now most people are using the similar technique now. And also for the temperature coefficient control, we have a big project working on it. And since we have solar cells transporting to all parts of the world, so the transportation and the guarantee of the no loss on the road is also a big part of the work as well. All right, so now let's move to the third session, which I want to share with you the most. So here I want to share about what do industry level R&D team do. So I think that will solve some curiosities from many of the audiences. Apparently, some of them looks like a PhD student, so they maybe have wondering what is going on here and what is our interest and what are our projects. So you will be quite surprised. So firstly, I want to mention what the advantages of for working at the industry level. So apart from having, I mean like the advantage of university level research such as UNSW research, you have a lot of talents here, so you have many new ideas. But you know, we have our advantage as well. For example, we have high throughput that can guarantee rich experimental data. For example, during the day, if we want to make a cell, we can make a few thousands of cells so that we can gain a very large amount of data. Then we can do the analysis very detailedly. And also because we have the production running every day, so we have a baseline for the result. So we can get the baseline from the production line, which makes the comparison very reliable. Even you have, for example, efficiency gain of 0.1, that still count because, you know, when you compare to the variations at the production line, it's probably only 0.03 or 0.04. That is the variation for the production line. So that's accurate enough. And also we have access to the latest technologies and equipment, you know, because the equipment manufacturers, their main purpose to sell tools to the industry. So they're keen to have their latest model to the industry directly, so that once they're happy, they can buy them. So we have the latest information all the time. And also we have a system from and characterization and also loss assistance provided by our collaborator partners such as UNSW and AAU and many other partners globally. And also because, particularly for solar cell research, we are an integration company, so we have the help from the solar wafer department and also the solar module department, which can help us to constantly monitor what is going on here and whether the improvement we have made here, whether it's really can be delivered to the customer or not. These advantages significantly benefits the industry players. That's why a lot of good result has been achieved by the industry players in recent years, such as you know, we have done some good job, and LONGi just made a very good high efficiency cell last month. And Trina, of course, is one of the leading companies for technology innovation. And for N-type, LG is doing a great job as well. So I think that's due to the combination of these benefits here. However, for us, apart from these advantages, there are many disadvantages. So, you know, the work is actually complicated. So this is the real world. This is how we work at the industry level. So, so I made a graph of distribution of R&D focus based on a number of projects. So it's based on like what projects we are working on. I have to point out, it's just number of projects. It doesn't mean like we spend equal effort on one project, but it's a good reflection as well. So, so this is what people think we should do. So efficiency gain technology development, such as trying to develop new high efficiency solar cells and, you know, try to improve the texturing, improve the metallization and stuff. And also when you have a good technology, you want to bring the technology into the production line, then you can do a new product launch. So these two parts are considered as a typical work or expected work for R&D center. But actually this is only count for half of our total work. So what are the other halves? So another important part is the quality and reliability improvement project, such as, you know, for the product we have LID problems, PID. These days people talk a lot about the LETID and many others like the UV and also we have to, like I mentioned, we have to meet the requirement for more strict standards. So these need some R&D work. So we not only need to know what is the mechanism behind the degradation, and we also need to know how to solve or how to release the degradation. Then we can, have a more leading position in the quality war. So that is a very important part as well. And here I just show this is the the market investigation last year. So it shows the people's users' requirement for quality standards. For example, here China, people mainly using one-time IEC, but in Japan, people have been looking at products with double IEC already. However, like in China, users are catching up very quickly. So a lot of tenders these days require some report for double and triple IEC test. And for Middle East, because they're hot weather, so they require some special tests as well, double AC and even temperature circle 500, which is quite significant change. And here no one shows a requirement for triple IEC. However, just starting from this year, we have seen some inquiries about some more strict test for triple IEC and from the US market and also from the South American market as well. So that means like the trend is people are asking more. When users are asking more, that means like we have to provide a better quality product. That's why this quality part of investigation and the improvement is account for quite significant part of our job. I'm just giving an example by the LETID study. So the left green part shows, so we need someone to identify the problem. So apparently the users and also ourselves, we have identified the LETID problems for the modules and cells. So that means like in the hot weather power plants, they may suffer from this. Now what should we do? And we prefer to have a combination of effort into this topic. So for example, we are working with UNSW Hydrogenation Group, and we are trying to understand this problem. We are trying to understand what is LETID and how we can solve the LETID, and like the mechanisms and what are the possible causes, and also comparison between products and between companies and stuff. And then we try to find solutions and we do the reliability test together. And during this work, we have maybe gained a lot of experience, but at the same time, we cannot stop. We constantly try different approaches to see which one works. So at Jinko R&D, we try to scale up the test. We try to, maybe one topic and one possibility has been discussed here, and then we start to try it already on the scale up situation, just to make it faster. And we do the stability monitoring as well. So we know that may work in a laboratory condition, but we need to know whether it's in a product state, whether it's still working or not. And then once it works, we will do the product updates as well. So as you can see, it's a combination of everyone. So like LED, LETID, we need to have the effort from the university, from the institutes, and also from the effort ourselves. But also, most importantly, we want to make the users happy, the customers happy. So we need to have the combined test with them as well to guarantee that they has been issued good products. Okay, and then the next part is all sorts of problem solving, endless problem solving. So there's a lot of problems happening during our work. So like I mentioned the integration problems, like such as when your wafers get thinner, then you may have breakage problems, and you may have the printing maybe is become harder. So we have to solve it. And also when you shift the resistivity, and then we have to solve to find a solution to optimize the whole process, such as diffusion, maybe the paste as well. And also for the module EL failures, such as EL failures, we have to find a way to solve the problem, or at least try to stop problems on the solar cell side. From that, I mentioned packaging problems. It's very difficult to imagine, but because some of our solar cell has been made different location as the module factory. So I have to transport the solar cells, and then how you package it, and how to avoid the the degradation and the damage during the transportation is very critical. So we are actually helping to design the package as well. So that's it doesn't sound like an R&D job, but that's the truth. We have to work on it. And also, we need to solve the mass production problems, such as the efficiency variations. We need to help to find out why, and we need to solve the problems and together with the production line. And and also, for example, when the A product rate is dropping, we have to find out why it's like that. Once there is a change of the BOM materials, and that means there will be many tests and certifications will be done here at R&D Center ahead of a large implementation at the production line. So as a conclusion, the R&D engineer in the industry needs to be very cautious, humble, and comprehensive thinking. So we need to be prepared for new problems coming all the time, and we need to have a quick reaction of what we can do. Maybe not the best solution, but at least you should try. So that is how we do. That means like when we do a lot of work like this, that means we have limited time to do the cutting edge explorations. And many of the work are exciting, is exploring, but also risky for us. That means we need to, we prefer to have partners to work together on cutting edge technologies and all frontier technologies. That comes to our collaboration with research institutes and universities. So we have a global technology collaboration network, and some in Europe and some in US and Singapore in Asian areas, and well, the largest fund, Australia. We have partners here at UNSW and ANU. So we are trying to make full use of these collaborations to work with our partners to know which part is their best, they are most good at, and which part we can join to help. So these combinations will make our R&D work more efficient and more smooth. And also a global collaboration network can enable our ability to touch the students. So we know that in case there is anyone interested to work with us later as a career, so we are happy to do that too. So we have done a recruitment talk this week, this Monday, which is quite successful. So I think it's a good start for us to globally seeking for talent and graduates, good graduate students and stuff. And also for the research collaborations here, I mentioned a few things we think is important. So it's all also as a last page, it's also a good point we can discuss, and we can talk about what we can do together. So a few areas we are we have a lot of interest. The first one is application type of technology, such as hydrogenation and advanced passivation and metallization, which can be used strictly into the production line, into our current product series, and some improvement and stuff that will make us benefits from this kind of work very quick. So this is a number one interest for us, and we are working on that in many areas. And another part is the fundamental studies, and this is what the universities and what the researchers are good at, and such as loss analysis, structural optimization, and also studying the mechanisms for degradation. We are working with a university in Norway, Oslo University. So they are working on very fundamental studies of defects found during the cycle of during the cycle of the solar cell performing, such as like you have daytime, you have nighttime, and then during the cycle you may cause some extra defects during this cycle. You have current, sometimes you don't have current, and the temperature changing very quickly. This type of defect cannot be found during during the laboratory activated aging test because you are under light constantly. So this type of work we are very interested because they may lead us some clues on what is going to happen in the real world rather than in the lab. Just an example, and there will be other topic as well. And also we have work on the international standards because a lot of PV is actually a very young industry. So a lot of the standard has not been set up, and due to we have a lot of industry partners, players already. So it's getting very difficult to get everyone happy about the new standard. So that's why we need a comprehensive group with people from all areas, from research, from industry, from the certification organizations. Then we can work together to set up new standards for everyone to use in the future. Just giving an example, the bifacial cell and module measurement is still under discussion. It has been under discussion for a long time, as far as I know, for 3 years. But that means like we have new results coming all the time, especially last year and this year. So I have a feeling that things are getting there. So I think that's a good start where a lot of institutes has contributed to this study. Then the third-party view is very beneficial for this type of work. And also the last, the renovation is like more new novel ideas for next generation technologies. I don't mean particularly these technologies, but I just giving a clue that some new ideas will be very interesting for us because we need to know that what may cause a dramatic change to the industry and to the PV whole PV research world. So we're interested in collaboration on this as well. We don't have the ability to work on the ideas, but we can provide a resource and facilities and even some reliability tests. That is what we can do. So we are happy to do collaboration in these areas as well. Just as a summary, we are open to research in all areas, and that is also like an important reason why I came here today to have a chance to discuss with people here. So I want to be inspired with some discussions and to bring back some new ideas, and then they can work on later. And that's it. Thank you very much for your time.